All right, well, I am Dan Stone. I'm a product manager on the Google Analytics team focused on our user-centric analytics and some of our audience marketing integrations.
My name is Nima. I'm a tech lead on Google Analytics team.
And today we were going to talk about some cases of how the analytics and marketing worlds are colliding and what some of the more advanced advertisers are doing to take advantage of the rich data that they're using in Google Analytics and deliver better experiences for their users through their marketing activities. All right, let's try this again. So in addition to talking about what some of our customers are doing that are really interesting use cases, we'll also be touching on some of the things that we are doing to try to make this process more approachable for less sophisticated marketers, to be able to take advantage of these same techniques. Compared to some of the other sessions that you've sat through today, we're going to be more focused on kind of the real-world use cases of some of this data and probably less into the deep diving on the data science behind it. So before we get started, how many of you work with marketing in your day-to-day activities? Great. And how many of you use customer demographics or behavior data to try to predict or in some way influence marketing behavior for end customers? Great. And how many of you try to do this in real time when these customers are on the way to make a purchase or make an important decision? Yeah, only a couple. And it's really hard because you have a ton of data and you have information coming from all kinds of different sources, and it's really hard to actually tie together all of the pieces and make this actionable in real time. And so it's easy to focus on kind of one-off prediction models and figuring out which users are more likely to purchase or churn, but it's much harder to tie all these pieces together. So what we'll be touching on today is a quick kind of overview of some of the techniques to do this and what some customers are doing, and then talking about some of the things that we're doing to make this simpler for marketers. So for those of you who might not be as familiar with remarketing, remarketing is a tactic whereby you can use some information about a customer's interaction with your business, whether it's a site or app, and then re-engage with them later on to help drive them toward a decision or an outcome. And traditionally, it evolved from sort of a very performance-driven tactic to help bring users back to your site and convert, because for every dollar that you spend trying to bring users to your site or to your app, 98% of that value was essentially wasted, because only 2% of users typically would convert. And as a result, remarketing was a really powerful tactic to allow marketers to plug the leaks in their funnel. But it evolved from here, from sort of a purely performance-based tactic to a tactic that can be used much more creatively to basically optimize and enhance experiences after a touch point with a customer. So in addition to helping drive the purchase, some marketers are using this data to be able to follow up with customers after they've purchased and suggest a video tutorial on how to use the product, or to use the same data and cross-sell some of their customers to other products that they might want to buy. And so this is an example where we start requiring much more data to do this type of analysis. So if we zoom out for a second and we think about the types of data that a marketer and many of you are working with on a day-to-day basis, there are all different types. And that's one of the reasons why this project is so challenging is because you have so many different types of data from so many different sources, and it's rarely in a consistent format. So just for those who are a little less familiar, we have kind of the main unit of data is generally a page view on an advertiser's or a brand's site. And this can be tracked in different ways. Generally, advertisers will have all the page views tracked using an analytics tag of some kind. They'll also be tracking data in their apps. And they'll be using what we call measurement protocol for basically anything else. So what are the other things? Sometimes the page view is not the most important action that you actually want to measure. Sometimes the more important thing is the conversion or the video play or the cart addition, whether a user submitted a form. And this is tracked through events, quite often with analytics tags, which adds another dimension of data in the system. And an example of how this looks like is you would send an event in the tag that would say, this is an event, video, click, play, and perhaps some additional metadata about the event. Another type of information that is often measured is social interactions. So whether someone has interacted with your social share buttons, you can track using the same format. And then the other type of tracking or measurement is using enhanced e-commerce tracking, where you might want to understand how far a user made it through the funnel, whether they got to a product view or a cart addition, internal promotion, checkout, or finally a transaction. And this is all done through different code implementations, which adds another dimension to this universe of data. And we're just talking about online interactions so far. Beyond what happens online, there are many ways to import sort of custom dimensions and metrics. Things like the customer type or the lifetime value status, as well as metrics like the total number of purchases over a lifetime, or the offline revenue that the user has generated, or even sometimes things as crazy as what temperature it is in the location where the user is coming from. Perhaps you sell more umbrellas on rainy days or during times when there will be rain. And what's important is to make sure you have all this data in one system where you can then do the analysis. So when we look at it all together, we have over 250 dimensions and metrics that marketers are using right now to try to build better experiences with their users. These cover things from behavior to events to e-commerce, where the traffic came from, demographics, and technology. And for sophisticated marketers, this means that they have a lot of opportunities to really get fine-grained with their audiences. So if we think to kind of the traditional starting point for a lot of marketing, a lot of marketers would start with sort of behavioral funnel stages or conversion stages based on where the user gets to on the site or app. So recently we had a large online travel agency that had started with behavioral segmentation based on homepage, category page, product page views, cart abandonment, and then finally past purchasers. And what they realized is that two people who were at the exact same point in the conversion journey, let's say the very middle one, where they're at the product page, they would actually respond very, very differently to the offer that was presented. And what they later realized is that there were very different segments of their customers that behaved very differently. And so they took a step back from this traditional approach and they applied clustering analysis of their customers, and they realized that there was a business traveler segment that behaved very, very differently, that was completely price insensitive and cared more about perks and rewards. And so then they reran their models and they realized that there were vastly different sort of decision points for each one of these customer segments versus when they treated all of their customers as a group. So what they did is the same travel agency took their GA data with all of their custom dimensions, all of their events, and they exported the raw clickstream data through Google BigQuery. And they then ran it through their own analytical systems and produced a decision tree for each of those customer segments that then told them users that had spent more than X time on site and had come from this sort of campaign should have this likelihood to convert. And then they mapped that back into Google Analytics and built audiences that they could then re-engage with their users better with. And one other example is in telecom. So we're seeing this kind of all across the board, across verticals. We had an example recently where British Telecom used a similar approach, and they were able to achieve vastly lower cost per acquisitions and much higher sales volumes using this sort of approach than what they had previously done, even when comparing it to their most successful remarketing tactics to date. So that's an example of what some really sophisticated marketers are doing today using their analytics data and then mapping it back to actually provide better experiences for their users. And next, we want to talk a little bit about what we're trying to do to make this process a lot simpler for the companies that maybe don't have an entire data science team in-house, but still want to be able to take advantage of some of these tactics for driving performance. So if we think back to all these signals that marketers have, in the case of a really advanced customer where they can make use of all this data, it's great. But in some cases, too many signals can actually be overwhelming, and they can actually hurt. And when we also factor in all these other data sources, some marketers don't even know where to start. So that's where we tried to help optimize this experience. And I'll turn it over to Nima to talk through what we did.
Thank you, Dan. So to illustrate how we do the training and inference to do prediction for conversion, here's a very simplified example that shows you a sample of training set that we take from anonymized visit data from the historical data of a single website, usually ranging from 30 days to 60 days or 90 days of data. Here, as you see in this training set, each row represents one anonymized visit, and the middle columns representing some of the features that we use in our modeling algorithms. Things like the origin, the country of origin, the medium, keywords, and source, as well as page views. On the rightmost column, it's the label that we use, representing whether there was a conversion at the end of that visit or not. We use this training data to train a logistic regression model. And then we use that model to infer the probability of a conversion in near real time when a new visit comes to this website. And based on the prediction of this probability of conversion, we can then make a decision on whether to target this visitor at this time or not. Now, more realistically, this is a very large-scale logistic regression modeling where we use many different features and crosses between these features. We use automatic template exploration to detect the best candidates for feature crosses. And we trained a large number of these logistic regression models for many different websites concurrently. So just to illustrate some of these features that come up as important in these models, here's some examples that you see on the left side. Things like hostname crossed by request URI, which essentially captures the landing page that the user came in to the website from, and a few other examples there. Also, on the right side, it's a plot that shows you a distribution of various feature types that we have across two different dimensions. One being the average weight of the feature across all of the various customer-specific models that we have built, which captures how important, how predictive that feature type is. And on the x-axis, we have the cardinality of the feature. So we see that there is a very large range across both of these dimensions. And different features have different level of predictive power in these models. Now, one way that we use to measure the performance of our models is to evaluate them on the historical data that we have, on the held out test data, to come up with ROC curves such as this. This one is aggregated across all of the customer-specific models. And what it's showing is the true positive rate for various values of false positive rates. What this means is that based on your operating point, your decision point of what percentage of your traffic you want to target, you can adjust how much of the true conversions you can capture. So what we see here is that by targeting only about 10% of the traffic, we can cover about more than 85 to 90% of true conversions, which is a pretty good performance for these models. So this is a really nice result. However, these are models that are built for customers who do have sufficient amount of conversion, so that we can build one model for each customer. But we're also interested in helping smaller and medium-sized businesses who oftentimes don't have enough conversions or even don't have any conversion tracking. So how can we do such a prediction model for them? So one idea to address that is to go to a transfer learning paradigm where we train a model on an aggregate training data set from many different customers who do have conversion data, and they have opted into data sharing, so that this large-scale logistic model can capture a variety of patterns and user behaviors across all of these different types of customers. And then applying that generic user model to customers who do not have conversions data. In effect, transferring the learned model to these smaller customers. So evaluating this generic user model in a similar way, this is the performance that we get for this model, which shows it's slightly lower than customer-specific models, but still it provides really high value, high predictive power for these customers who wouldn't have this otherwise. Now I give it back to Dan to finish with final thoughts.
So we talked today about some of the ways that customers are using their rich data already to build their own decision trees and map that back into their marketing activities. And we also touched on one of the ways that we had tried to make this similar tactic available for customers that maybe don't have the sophistication to do this. And as we look at where marketers are going, this data is sort of used in concert with their existing bidding strategies in AdWords or other systems. And it's basically complementary to try to tie into the optimization that they're already doing. So a lot of customers started out with paying per click, and then we're moving to sort of an estimated conversion likelihood baked into that, moving toward bidding on conversions or cost per acquisition, and kind of in the future, bidding toward return on advertising spend or return on value invested. And so we're still in very early stages here. We have a lot more to do to make these models better and make it easier for customers to deliver the right experiences to their users at the right time. Thank you. I think we have a couple minutes for questions. Right there.
First of all, thanks for a great presentation. My main question is, this sounds awesome, but how much of this is actually available in the product right now versus some sort of exploratory work? Because I've been just through the process of setting up Google Analytics for what I wanted to make as deep tracking optimization as possible for a certain project. And much of this I wish I had right now, and I couldn't find.
Yeah, that's a good question. So the two sort of features that we talked about in the beginning, we mentioned Google BigQuery, which is an integration that is available for all Google Analytics Premium clients. And if you're Google Analytics Premium, then you should contact your account manager to get access to BigQuery, which basically gives you a really powerful interface for querying kind of raw session level and click level data. And in the second part of the presentation, we were talking about these predictive models, and they're actually available today as well for everyone. They're called smart lists. And they're still sort of in a pilot stage, but they are available for anyone to use. Yeah.
And I just wanted to ask a follow-on question. What I did not see in this presentation is discussion of attribution modeling. I'm very curious if you could speak to that. What do you currently do with attribution? How it's done? What is the product roadmap for that? And I'm sure many people would want to know what it is, so you might want to do the introduction as well.
Should I take that? Yeah. Okay. So for those who couldn't hear it or aren't familiar with the topic, the question was on attribution modeling. And I'm probably going to disappoint you because it's a really deep topic. So what attribution modeling is it's basically trying to account for the fact that a particular click that goes to a site or an open of an app may not deserve all of the value from any conversions that result from that particular session. And so attribution modeling is an attempt to attribute the value over multiple sessions or touch points or channels, including online and offline tactics, so that the last channel that drove the conversion doesn't get all the credit. And this is a really deep area. So what we've talked about so far assumes either a simplistic attribution model or that clients are bringing their own attribution model. For kind of more info on various types of attribution, I'd suggest you contact someone on the odometry team, which is part of Google, and they specialize solely on attribution.
Okay, do we have other questions? I think we've got one over here.
Incremental model update on your area?
I'm sorry, I didn't catch it.
Incremental
Do you
model.
do incremental update?
Yes, so the model update is actually a continuous process that it's a running process that continuously ingests data as it comes in. and it does the incremental updates every, I believe it's every few hours. Yes.
And another question I have is, what range of future numbers you are talking about? Is it thousands, millions?
Feature, okay. So in terms of the order of the number of features that we have, so the number of feature types is in the order of hundreds, but the number of feature values would be much larger than that. Like the specific instances that each feature type can take on, that's a much larger space. I don't have a good range in mind right now to give you, but it might be in the hundreds of thousands.
So, but the particular weight live on the feature values or the feature types?
I'm sorry, I didn't catch that.
So you said two things, feature types and the
Yes.
feature values.
Correct.
I try to understand what is feature value and the feature type
Right.
in terms of a weight. Where does the weight live associated with? Feature values or feature type?
So the weights are actually associated with feature values. So feature type is one category of a feature, such as, for example, page view is the feature type. And then feature values would be the different values that page view can take on, like various numbers. Feature, like page views equal 1 is one feature value, equals 2 is another value. And then in that sense, features are turned into binary features because each feature value becomes a binary feature, which is either active or not. Then weights are associated to feature values.
Another question I have is, you guys doing the logistic regression or deep learning? Why are you only doing the logistic regression? Can you share the insight of it?
Yes, currently we are doing logistic regression mainly because it's easier to scale and there's more mature tools for that, at least inside Google. So we are starting with this and we are getting really good performance on it. So we're happy with the performance at the moment. But of course, I believe deep learning can give you incremental improvement on the performance. But it's just not what we are focusing on right now.
Last question. How do you do the feature selection?
Right. So feature selection is actually done using a few different methods that do an automatic search in the space of feature crosses using a few different information theoretic criteria that I can't go into the details of it, but it's a few information theoretic criterion to select candidates that are likely to be predictive.
Yeah, one thing I'll add to that is that going in, we had hundreds of individual feature categories or dimensions, and we were surprised at how few really made a big difference. They were on the order of only a couple dozen.
Last question, I just remember. How do you do the model update? You know, what type of things you are doing to do the model update? Like online model update based on the LR?
So actually, I can't share that much detail about how the model update happens, but I believe the way this is done is so every model update actually goes over the last, for instance, 30 days of data to retrain the model, but But it does leverage the previous convergence points of the model as well. So it doesn't start from scratch. It starts from the existing convergence points to update the model. But uses the more data than just today's data. Yeah.
Okay, great. So let's thank our speakers.
Thank you.